Hi, I'm Sam Roberts, and today I want to show you the XYZ tiled export option in ProRaster. So we'll be looking at this export image option, which is on the raster processing menu. This is available in ProRaster Scientific and ProRaster Premium. It is not available in ProRaster Essential. Today I'm using ProRaster Scientific and I'm using version 4.2.04. So when I go into export image, let's find out what this thing is. I'll hit export image. Here's our first learning. It says you do not have a defined rendering algorithm. So you've got to first have a rendering algorithm. So, all right, so let's create something. Let's create a new algorithm just from Gebco. I'm going to change my color table. Right, there's my algorithm. Okay, now let's export it. Export image. Please save the algorithm before exporting it to a located image raster. So that's our second learning. You have to save your algorithm before you can export it. So let's save the current algorithm into C temp. We've saved it now, and now we can go into export image. Okay, and it brings up our export image dialog. Now the thing that I want to show you today is this new option on the output format menu. So in addition to our raster output formats, we have a new one here called XYZ OGC WMTS Tiles. And I did not invent that name. All right, so let's select that. And here's our next learning. Invalid algorithm coordinate system. To output to XYZ tiles, you must use blah 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 EPSG 3857. So we have to use this Mercator style coordinate system that Google Maps introduced in, I don't know, back in 2005. And it's called EPSG 3857. So that is a hard and fast rule. So let's go back to our algorithm and we'll change the coordinate system. So go up to the algorithm on the tree, hit the algorithm page, and you can see here that we have coordinate system override, nothing specified. And our coordinate system default is latitude, longitude, EPSG 4326. So I'm going to hit the Projection Explorer button and just show you where to find this thing. So go to Projections of the World, scroll down a bit, and you'll find Popular Visualization CRS EPSG 3857. Another way you can find it is just hit the search button and type in, say, 3857, and you'll get a list, and there it is there. So I'm going to select that coordinate system. So now it says coordinate system override is Projections of the World Popular Visualization, blah, blah, blah. And I'm going to save my algorithm, go back into export image, select XYZ OGC WMTS tiles, and now I'm able to do my export. So I'm going to start again and create a new algorithm just using OpenStreetMaps. I'm going to put some hill shading on it, so click on the intensity component. I'm going to choose Gebco 2026 and enable it. And just turn off that highlight, and I'm going to bring down that shadow a little bit. So there's my algorithm. We are in the EPSG 3857 coordinate system. So let's find out a little bit about this coordinate system. It's a conformal coordinate system, which means that angles and directions locally are preserved. So something that's 90 degrees on the Earth is going to be 90 degrees on the screen. However, there's a huge amount of distortion. So if I go to the equator here, I've got my target cursor turned on. My cursor is 3,000 kilometers wide at the equator. By the time I get up here to Scotland, it's 1,500 kilometers wide. And up here north of Greenland, it's 300 kilometers wide. So there's a tenfold distortion in scale from the equator up to the North and South Pole. Let me turn on my coordinates. So coordinates in this projection are in meters. So the northing around the equator is about 0. So there we go. We just crossed over the equator. And it goes from minus 20,000 kilometers in the west to 20,000 kilometers in the east, and the northing goes from minus 20,000 kilometers in the south to around 20,000 kilometers in the north. So the whole thing is perfectly square, and that's by design to suit this XYZ tiling system. The reason it is square is because they chop it off at the north and the south at just over 85 degrees. So those very high north and south polar regions are missing from this map. So let me turn that off again. So let's talk about the XYZ tiling system. Because this thing is perfectly square, it's very well represented by square images. So for example, I could export this out to an image that's 256 pixels by 256 pixels, and it would cover the whole of the Earth. The XYZ tiling system uses exactly that. It generates little pictures that are 256 by 256 pixels, and it has a resolution level very similar to the system that's in ProRaster. So that at resolution level 0, it's 256 by 256. You go up one resolution level and it goes up by a power of 2. So then it'll be 2 by 2 tiles of 256 by 256. So it'll be 512 by 512. Resolution level 2 will multiply by 2 again. So it'll be 1024 by 1024, which will be 4 tiles by 4 tiles, 16 tiles altogether. Resolution levels go from 0 right up to 23. By the time you get to that resolution level, you're generating a huge number of little 256 by 256 pixel tiles, trillions in fact. So this thing will, when you export out at high resolutions, it's going to generate a huge amount of tiles, something to be careful of. The export is different to exporting out to a normal raster. So when we export an algorithm out to a GeoTIFF, for example, or an MRR, we render the algorithm at the highest resolution. This is the resolution that you desire and you want. And we output that to the GeoTIFF, and then we generate the overview pyramid by downsampling that high resolution data. So everything gets generated from that base resolution imagery. But when you output to an XYZ tiling system, every level of resolution is generated by the rendering system. So if you have content that changes appearance as you change resolution levels, then that will be preserved in your output. And the things that do that, firstly in ProRaster, are things like contour levels and contour layers and point cloud layers. They change appearance as you go up and down through the resolution. And of course, things like web mapping, WMTS layers will change as you zoom in and out. So I'm going to add in a contour layer. I'm just going to use good old Jebco. And then I'll just make this line thickness a little bit thinner. Always seems to be the case that I need to cut down that line thickness. Right, so firstly I just want to show you that difference between exporting to a raster and building the overview pyramid and exporting out each individual layer. So perhaps if we zoom in to somewhere, well, let's zoom in, let's just look at say Tasmania. So right in tight there on Tasmania. I go into export image. I'm going to export out to an MRR file. So I need to set my file name. That one there. I'm going to use this clip to map option. So I just want to export the algorithm that is displaying in the map. Then I choose my resolution level. In ProRaster, resolution levels are centered at 0 and they can go negative and positive. And as you go higher, you get to a lower resolution. And eventually you get something like this. So probably do that. So let's process that. We'll export that out to MRR. Let me just open it in a different session. So that's what it looks like if we export to an MRR. So we've generated it at this high resolution level. You can see the contour labels here. But then the overviews have been generated just by downsizing that. So now I can't see any contour labels because they've become too small. On the other hand, exporting out to XYZ tiles generates each resolution level. So let's just choose that. Now I need to specify a folder in which it's going to go. So let's go test 01. Select that folder. Clip to map. Now choose my resolution level again. In this case, it's different. Hit process. It's now going to spew out all of those little PNG files. I'll just bring in a new instance again. And here's the file that we've just generated. Now I'll explain why I'm about to do this. I had to add in an overlay because you need to be able to find the data. So let me just turn that off now. So here's what we exported. So if we zoom in, we can see that we can see our contour labels. But as we zoom out, you can see the contour labels changed. So the resolution changed as we zoomed out, as it was generated at a different scale. So let's get into the nitty-gritty of what we're doing here. So firstly, select your output format, XYZ OGC. This format supports, a variety of different image formats. So you could use JPEG or PNG or WebP. But I am only supporting PNG, so it outputs to PNG. You can change the compression level, but I wouldn't bother if I was you. You can output red, green, blue, or red, green, blue alpha, and I always use RGBA. You must specify a folder. So if we come back to what I created before, let me just bring that in from over here. So we created a folder called test 01, and then when I did the export, it put in all these new folders. These are the resolution levels. So it went from 6 to 10. And if I go into one of these resolution levels, then it has a bunch of additional subfolders. These are, I can't remember if they're the rows or the columns, but then you go into there, then you find your actual little PNG files stored in there. And right at the bottom folder level, you'll see this little file called test01.xml. So this was also output from the export option. And this is a file that you can drag and drop into ProRaster, and it will display that export. So that's what I displayed before when we looked at it. So come in here. Need to create a new folder. The folder must be empty. So create a new one. If you want to do it again, don't overwrite the same folder. Go in and clear everything out of that folder and then do it again. Then we have our options. So we can go full extent, clip to map, or clip to a polygon, and then we can choose a polygon that we've used before or browse to a polygon that's in a map info tab file. So I'm going to use this clip to map option. So that's going to export only what you can see in the current extent of the map. Now you have to set your resolution level. Now, in a normal export option, you have the option to set the cell size and the size of the raster to anything that you want. Yeah, that is not the case with this XYZ system. The tiling system is rigidly defined. So the cell sizes at every resolution level are rigidly defined. They'll always be the same. So the only thing you need to choose is a resolution level that gives you an output that is the size of the output that you want. So you can take this up and down just like you can with an output to raster. So 0 is highest resolution, and as you go up you go to lower resolution. So that's consistent with the way that it works with a raster. However, the actual XYZ tiling system is back to front. So you can see that I can go up to 22 and I can go down to 0. In fact, that maps 0 to 22 in this resolution level system maps to levels 23 to 1 in the XYZ tile system, just for those who are familiar with that system. So at resolution level 0, I've got the highest resolution possible, and that is the highest resolution that the tiling system supports. It won't go any higher than that. And you can see that the cell size is 1 centimeter. And our raster size is absolutely huge. So we're going to go up a bit to make it a bit smaller. So as I go up, the raster size keeps getting smaller until I've got something that's easily output. We've got about 3000 by 3000 pixels. So let's process that. So it's going to bring up this dialog. It's going to output all of these little PNG files. And then when it's done, you can test to see what its output. So go to recent output rasters and you open that little XML file that it's put into the base folder. Now, as before, you can't see anything. The problem with an XYZ tile format is that its range that it reports to the raster system is the entire Earth. So north to south, east to west. And we need to zoom in to find the section that's actually being generated, because ProRaster doesn't generate all the resolution levels. It only generates the levels up until about 2 tiles. So once your system is like 2 by 2, then it says, okay, that's small enough. Nobody wants anything smaller than that. But it means I can't see anything. That doesn't mean there's nothing there. It just means that we haven't reached a resolution level yet at which something would be displayed. So you've got to zoom in to find the thing that you've generated. And that can be virtually impossible. So I put on a web map overlay. I know that I generated it here over in Tasmania. And as I zoom in, eventually, bam, there's my input. So that's the lowest resolution output that we generated. And as I zoom in, you'll see that it replaces that with higher resolution data from different levels in the tiling system that were generated. And then once you've gone to the highest resolution level, excuse me, it will just keep on zooming in, but now we're just interpolating from the image. So what else can I tell you? You can use this manual extent option, in which case there are only a certain number of things that you can do. You can set the coordinate range, and then that will change the raster size and so forth. But really the simplest thing to do is just to set things up in your map, or better still, use a clipping polygon, and then set that resolution level to whatever you want. So for example, I can now choose something at, say, higher resolution. Well, let's go down a bit. We need to make a new folder. Always make a new folder, or clear out the folder that you're working with. Hit process. Now we're seeing a bit of a larger processing operation. It's going to generate thousands and thousands of files. Now, as I said before, if you if you go for maximum resolution, it will generate trillions of files and destroy your PC. So don't do that. Be aware of what you're doing, and keep it modest. The goal of this is not to produce web maps for the whole Earth so much. It is to produce very high resolution maps that you can use on things like a GPS, and we'll be looking at that in another video. And just another note, so let's have a look at that one. What it generates is all these little files on disk. What people will often do then is jam all those little files into an MB tiles file. And perhaps in the future we'll make that as an option. You can do that with GDAL. So you need one of the GDAL executables, one of their utilities, and you can export all of the PNG files that you've created in the directory structure that ProRaster has created for you into an MB tiles file. So you just get a single file, and that is the sort of output that you'll generally use if you want to upload this to the web. So for example, there are sites that you can upload this data, and they'll set up your own little map, and you can do it for free, and you can have your own little map displayed on the internet that people can access for free. So that's one of the applications for this. Though the application that I had in mind when I was doing this is that I want to get high resolution maps into my GPS. So I'm generating offline maps for my GPS, and I use that using this Handy GPS for Android and Handy GPS for iOS offline map options. But they're just like the XYZ tile system, just slightly modified, but otherwise exactly the same, and the same kind of process. So I'll be looking at that next.